Everything that we know about how cities are going to grow in the next few decades tell us that, by 2050, the need for urban water is going to increase 80% as people move towards the cities, which means that over the next few decades, what we're going to see is an increasing conflict between cities and their peripheral agricultural areas for primary access to water. Who gets the water first? So in that context, wastewater agriculture is a way of having the same amount of water be used more than once. So the question becomes, how do we start to rethink our cities in such a way that we actually could be capable of sending wastewater to agricultural areas without endangering our own food supply? All of the problems that you get with the accumulation of contaminants in soil have been accumulating in Mexico City for longer than anywhere else. So Mexico City is a way of seeing our future. It's a way of seeing what the future implications are of continually irrigating with urban wastewater. And so that's why we look at this system, is because we think, well, if we can understand these problems and if we can find solutions to these problems, then the rest of the world can really learn from this. What we're really trying to do is to produce a body of collective research that helps frame a very complex problem. And the big kind of conflict in this region right now is between farmers who would prefer that Mexico City not treat the water and the kind of national water regulators in Mexico City who do want to treat the water. So the farmers don't want to treat the water because it contains all of this valuable fertilizer, but the wastewater treatment plant is essentially removing that organic matter and processing it into a kind of sludge. And the farmers were supposed to be able to use the sludge, which would reduce all the pathogens and things like that, and potentially make their farming practices safer. But the sludge is also full of heavy metals. Without that, that means that they have less organic matter in their treated water, less fertilizer, which means that they have to finance the purchasing and distribution of fertilizer onto their agricultural fields, which is something they never had to do before because it's always just come in the wastewater for free. The studio that I ran in Mexico City, we were able to visit the farmers whose lives and whose agricultural incomes depend on the kind of environmental solutions that I'm describing. We were able to taste the pulque that they were producing in their agave farms. We were able to go to the landfills that were producing heavy metal contamination. Our role is not to generate the solution, but our role is to point towards possible fields of solutions that are out there that might actually work. And I can offer that to students as a design question. And then when they explore in their studio possible solutions, I take those solutions back to the people I work with in Mexico. So there's a way in which there's also potential for experts in Mexico to come back here and help us think through our environmental problems in St. Louis. There is an incredible, incredible opportunity here to rethink the way that we do things. And the only way that we can reuse water in order to have food, in order to support our rural communities who then support us, is to simply create a better urban environment, a healthier urban environment, a cleaner urban environment, an urban environment which would also make us less sick. I see a possibility of an incredibly bright future for Mexico City, for the Mexican Altiplano, for arid cities all over the world who want to think through soil as a way of reusing water, as a way of addressing water scarcity and climate resilience.